Hello everyone, welcome back to Spectrum Classes. In this video, we are going to discuss about the Lewis structures, how to draw the Lewis structure. So here you can see few of the atoms with their outermost electrons that has been represented as dot structures. So in this video, we are going to see how to write the Lewis structures in 3 simple steps. We are also going to discuss the exceptions of Lewis structures. For example, sulfur is having extended octet. So that we are also going to discuss here. With more than 20 examples, we are going to summarize these Lewis structures with complete concept, and we are also going to show you the tricks through which you can easily understand the concept and you can easily draw your Lewis structure of a given compound. So here I have just summarized few of the elements with their outermost electrons. Now the question comes, what is called outermost electrons. So the shell which is not completed over here, say this is 1s2, 2s2, 2p1. So this second shell is having 8 electrons maximum, but here in this case we are having 3 electrons in this second shell. So this is incomplete shell. So the number of electrons which are present in the incomplete shell is its outermost electrons, right? So here we have just highlighted the dot structure for these outermost electrons. Since hydrogen is having 1 electron in its outermost shell, so H and this 1 dot. Lithium is again from the same group, so it is having 1 electron. This is beryllium, so 2 electron, 3 for boron, carbon 4 electrons, 5 electrons for nitrogen, 6 electrons for oxygen, and fluorine 7 electrons, right? Now I'm just going to show you. So here in this slide I have just summarized the elements which are below these elements which we have discussed previously. Now these are the outermost electrons structure of these elements, right? And since these are showing ionic bonding with lithium and beryllium or first and second group, therefore, or they are mainly in ionic structures, right? These boron and aluminium is showing less than the octet, right? So this is again a different type. These are forming Lewis acids that we are going to discuss later on. But here from carbon to fluorine or silicon to chlorine, we are having covalent bonding. For this covalent bonding and hybridization, we are using this Lewis structure, right? So these are the outermost electrons. So nitrogen is having 5. Similarly, phosphorus is again having 5. Now the simple rules to calculate the number of electrons to draw the Lewis structure, right? So here I'm just going to write down, but these are little theoretical. I'm just going to discuss here in this slide. So step number 1 is to calculate the total number of electrons to complete the octet. So here in this case I'm just going to tell you how we are going to calculate this. So this is our carbon and this is our oxygen. So 3 atoms are there and all 3 atoms are going to complete their octet. Oxygen is also going to complete its octet. So you just simply add all 3. So this will gives us either this method you can apply or you can simply write down 3 atoms are there which are going to complete their octet. So simply multiply with this 8. You are going to get this 24. First step. So this is how you are going to get total number of electrons. Second, total number of electrons present in the outermost shell. So this is the important point. So outermost shell, how we are going to calculate. So I just discussed, this is having 4, this is having 6, and this is again having 6. So in this manner we are having 16 electrons here. So this is for carbon and 2 oxygens are there and each oxygen is having 6 electrons. So in this manner we are having 16 electrons here. Now the third step is calculate the shared number of electrons. So this shared number of electrons means these which are going to form the bond. So here in this case 24 which we have calculated in step 1 minus the number of electrons in the outermost shell in the second step we have calculated. So just subtract the second step electrons from the first step electrons and we are going to get this 8. Means 8 electrons are going to be shared. So 2 from carbon, 2 from oxygen, and here again 2 from carbon, 2 from oxygen. So 8 electrons are there. Now if you want to calculate this point also, how many electrons are there which are not going to be shared, then you can easily calculate that by subtracting from outermost electrons to shared electrons, right? So 16 minus 8, we get 8. So these are the simple steps. Now I'm going to summarize this, right? I have divided it into three different parts. One is for hydrogen as well as for fluorine. Second is for carbon, nitrogen and oxygen. Since nitrogen is little different, it is having odd electrons. However, carbon and oxygen both are having even electrons. And these three, carbon, nitrogen and oxygen, are going to complete their octet. However, in case of phosphorus and sulfur, since these are in third step, so they are showing extended octet also in some of the cases. So I have divided it into these three categories, right? So here I am just going to tell you, this hydrogen is having one electron, so it is also going to share one electron with the other atom. No coordination bond is there, no double bond, triple bond is there, right? So this kind of bond formation takes place, H and F. Rest of the electrons remain as lone pairs. So this is the structure of H and F. One more thing, if your compound is having H and F, then they are most of the time be on the terminals, right? That we are going to discuss. The next point is, if your molecule is formed by carbon, nitrogen, oxygen or sulfur, and these are the central atoms, then you can easily calculate your total number of electrons. So A is total number of electrons, B is sum of the outermost electrons, and shared number of electrons A minus B, plus minus charge, which charge is there, that I will discuss while we are solving the problems. This is the unshared pair of electrons, this is equal to B minus S. Total number of outermost electrons minus shared electrons. Now the important highlight is for nitrogen is this. This is for my nitrogen. Since nitrogen is having 5 electrons, right, odd number of electrons, so most of the time it is forming one double bond, one dative bond, here you can see arrow, and one sharing electron or one single bond. So here I have written one double bond, one single bond, one dative bond. Dative bond means this nitrogen is giving these two electrons for the bond formation, or in addition to that it can form triple bond. So these are the only way how your nitrogen is going to be form a Lewis structure. One, if your charge is negative, then add this. If your charge is positive, then subtract it, right? So this is the only condition. Now, so this is for carbon, oxygen, and this is for nitrogen. Now coming to the phosphorus and sulfur. So phosphorus and sulfur in some of the cases shows 10 electrons as well as 12 electrons. So we are going to discuss. This sulfur is forming most of the time with this oxygen double bond, right? If no charge is there, if charge is there, only then it is forming single bond. So these are few highlights through which you can easily make your Lewis structure. So let's start with the example. So first we are having hydrogen. This hydrogen is having one electron in its outermost shell. So this is how it is going to be bonded with another hydrogen and form a single bond. Now coming to the next species, which is NH3. So this N is having 5 electrons. 3 is bonded with the hydrogen. Here you can see this green and blue, green and blue, green and blue, and this left as lone pair. One more thing, hydrogen always completes 2 electrons. So here you can see this is the single bond which is formed by the combination of hydrogen and nitrogen. So here in this case you can see each of the hydrogen is having two electrons completed. This is how your hydrogen is going to be present on the terminal. Apart from that, this nitrogen is going to be to complete its octet. So here you can see 8 electrons are there. So this is you have to check. For in case of hydrogen, 2 electrons must be there, duplet is completed. And for carbon, nitrogen and oxygen, octet has to be completed. And this is again going to be shown by this, right? Now the next example, PH3. PH3, P is from the same group of nitrogen. So it is again having 5 electrons in its outermost shell. Each 3 of which are going to combine with each of the hydrogen, and 2 remains as lone pairs. So here you can see. Now you can also count your electrons. So each hydrogen has completed its doublet and this phosphorus completes its octet. So here is the complete octet. Now the next example, this is oxygen. Oxygen in its outermost shell is having 6 electrons, and this 6 electrons again another oxygen is having 6 electrons. So how to complete the octet, that is the main important point, but otherwise we can calculate 2 into 8, it is 16, and 6 into 2, this is 12 electrons are there in the outermost shell. This is total electrons, so 4 electrons are left, 16 minus 12, so 4 are going to be shared here, you can see, right? And now complete octet, you can check, this is having 8 electrons, this is again having 8 electrons, so both are completed their octet, and this is going to be shown by this. So here is the double bond, just because of this double bond, this sharing, this is a double bond, and rest are left as unshared electrons, right? Now coming to the next example, ozone. So ozone, here no matter of central atom because all are same. So these three, and each is having 6 electron in its outermost shell, right? Now how we are going to calculate? So 3 oxygen are there, each is going to be complete its octet, so 24 electrons are there in total, total electrons are 24. Now in outermost shell, how many electrons are there? So 3 into 6 is equal to 18. Now how many shared electrons are there? So 24 minus 18 means 6 electrons need to be shared. Here you can see for 2 oxygens we are going to share 2 electrons, and for 1 we are having dative bond. Since this is even number, oxygen is having even number, so there is no triple bond, right? So generally we are having double bonds in this case. Now this can be shown like this. Actually in previous books we are having this kind of structure. But now in the recent text we are not having this dative bond over there. Instead of this dative bond we are having formal charges over there. So this is electron deficient and this is electron efficient. So while we are doing the organic chemistry, then these formal charges will help us to decide the electrophiles as well as nucleophiles, right? The next example is uh, carbon and oxygen. Now the question comes, which is your central atom? Now here we are having 2 atoms, so there is no question is of having central atom. Now how we are going to calculate? So 2 atoms are there, 8 octet has to be completed, so 16. Carbon is having 4 and oxygen is having 6 outermost electrons, so 10 electrons are there. Now 6 electron has to be shared. So 6 electrons, how it is possible? So here 4 electrons of oxygen comes over there. You may also have a question, why not this 4 and this is for oxygen? If we draw, we can also draw in this manner, you can have a question, right? Since 6 electron has to be shared, so this can't be possible because in this manner octet of carbon remains incomplete. However, in this case octet of carbon is completed and octet of oxygen is completed. So this is the structure which is appropriate. Here we are having this triple bond, and out of this triple bond one is dative bond from the oxygen to carbon. That is why carbon monoxide in inorganic chemistry is very important, and this will be described by molecular orbital theory. Now coming to the next example of CO2. So for this CO2 you can calculate 3 atoms are there multiplied by 8 because each has to complete its octet. So here we are having 24. Carbon is having 4 and your oxygen is having 6. So 6 2s are 12. So this is having 16. Now how many electrons has to be shared? 8 electrons has to be shared. So here you can see 8 electrons are shared in this manner. But since here 3 atoms are there, so question arises which will be the central atom. So carbon, because this carbon is on the left hand side of the oxygen, or this is more electropositive, therefore this will be the central atom. Oxygen can't be the central atom. So first of all you need to decide which is the central atom, then you have to calculate the shared electrons. So shared electrons are 8. so evenly distributed. Now you can also calculate how many unshared electrons are left. So 16 minus 8, you are having 8 electrons, right? So 4 plus 4, 8 electrons are there, and this will be defined by this structure, right? The next example is carbonate. So in this case, here we are having this minus charge. So this is interesting. Here 4 atoms are there and each has to complete its octet. This carbon is having 4 electrons and 3 into 6 electrons. So how much is there? 22, right? So 10 electrons are need to be shared. But apart from this, we are having minus 2 also, right? So this where this minus 2 will go? This minus 2 will go to this total electrons, this. So 22 plus 2, if we are adding this, so 8 electrons has to be shared. So this is very, very important. We are generally thinking about this 10, but now we are thinking about this 8. So 8 electron has to be shared. So 4 electrons are there, 2 electrons are there, 2 electrons are there, so total 8 electrons has to be shared. So this minus sign has to be added in the outermost shell electrons. This is important and very interesting, right? Again and again I am saying this. Now here you can see this negative charge is represented by this green, so I just simply write down here in this manner. So this X comes from your negative charge, right? So in this manner it is forming single bond with this, which are acquiring the negative charge, and double bond with the oxygen. And here you can also see the octet of each atom. So this oxygen completes its octet, this oxygen again completes its octet, this completes its octet. And what about the carbon? Carbon again completes its octet. So this is our mandatory condition. Now coming to the next point. This is our CO3, and here if we are just going to remove this minus charge, then we can write down H2CO3. So here is the structure of H2CO3. So instead of this minus sign, we are having just one single bond. So just because of this single bond, no extra electron is there. So 2 electrons of oxygen are in this manner we have written. One is shared with hydrogen and the other one is shared with carbon in this manner, right? So here you can see this is shared with oxygen, this is shared with hydrogen. So this is our molecule, right? I'm going to discuss in the next video just because of the length of this video. I hope you find this video helpful. If you find this video helpful, please like, share and subscribe. Thank you all. Thanks for watching.